All right, welcome back. Today, we are jumping in the time machine and heading all the way back to 1997. Why? Because we're talking about the genesis of it all, the original IEEE 802.11 standard. This thing is the blueprint, the very document that kicked off the entire Wi-Fi revolution. So, let's crack it open and see what was inside. Now, just a quick heads up for everyone following along with us. This is the second part of our 20-part deep dive series, and it's all based on a really comprehensive technical tutorial from the folks at RFI Detectives. We're going through these standards one by one, so if you're an IT pro, a network engineer, or just love this stuff, believe me, you are in the right place. To really get a handle on where we are today with multi-gigabit speeds and Wi-Fi that's basically like oxygen, we have to go back to where it all started. And that was a very different world. One totally dominated by the screech of dial-up modems and a tangled mess of Ethernet cables. And the pivotal moment is right here, 1997. This is the year it all became real. The IEEE officially ratified the 802.11 standard, and just like that, we had the first ever formal specification for a wireless local area network. This was no longer just a cool idea in a lab, it was a standard. So what was actually in that original blueprint? What were the core technical specs that engineers had to build on? Let's break down the foundational components of this thing. Okay, this table really lays out the three pillars of that first standard. First up, you've got the frequency band, 2.4 gigahertz in the ISM band. ISM stands for industrial, scientific, and medical. And the key thing here is that it was unlicensed, which meant it was open for this kind of incredible innovation. Then you have modulation, how the data gets encoded onto radio waves. And it actually defined two competing methods, DSS and HSS. And finally, the big one, the speed. 2 megabits per second. That was it. That was the absolute maximum raw data rate. It's almost funny to think about now, right? When we're streaming 4K video without even blinking. But back then, just achieving a stable, reliable wireless connection at that speed was a massive, monumental achievement. And what's really interesting is that the standard didn't just bet on one horse. I mean, to make sure this brand new technology would actually work in the real world, the IEEE included two totally different physical layer technologies. It was a pretty smart move, really. It gave vendors options and kind of hedged their bets on which one would end up being more robust. So on one hand, you had DSS, direct sequence spread spectrum. The simplest way to think about this is spreading your signal out across a wide fixed channel to make it tougher against interference. And on the other hand, you had FHSS, frequency hopping spread spectrum, which, like the name says, rapidly jumps between lots of narrow channels. It's a fascinating look at two completely different engineering philosophies trying to solve the same problem. And this quote just nails it. The mission of that first standard wasn't about getting mind-blowing speed. It was all about reliability. It was about proving that you could have two different paths to get to the same fundamental goal, just stable, untethered network communication that actually worked. So yeah, it's easy to look back at 2 megabits per second and have a little chuckle, but the legacy of this original standard is absolutely immense. It's not some obsolete piece of history. It is the bedrock. It's the foundation that every single thing we use today was built on top of. And you can see its legacy right here. It established the 2.4 gigahertz band as Wi-Fi's home turf. It proved, and this is so crucial, that a commercial wireless LAN was actually a viable idea. And because it worked, it paved the way for every single amendment that followed, from 802.11b to G to N, and all the way to the insane multi-gigabit speeds we're starting to see now. I mean, the journey from that humble 2 megabit per second beginning, it's been nothing short of staggering. The scale of progress is almost hard to wrap your head around. But every bit of it traces its roots right back to this document from 1997. And today, we're on the verge of the next massive leap. IEEE 882.11b, and yeah, that's BE, so don't get it confused with that early B standard. You probably know it better as Wi-Fi 7. It's promising not just faster speeds, but something the spec calls extreme throughput and incredibly low latency. We're talking a monumental jump in what's possible, designed for things we only dream of today, like flawless VR and rock-solid industrial automation. So that brings us to the big question, doesn't it? What was the catalyst? What was that one breakthrough that took Wi-Fi from being this 2 megabit per second niche technology and turned it into the mainstream necessity it became just a couple of years later? Well, that is a story for our next chapter when we dig into the absolute game changer, the 802.11b standard from 1999. I'll see you then.